ready to go here. So Bob, it's all yours.
Okay, yes, this is the 10th of October, and I will speak a little later about some topics related to Dr. Werner and the Spitzer Space Telescope. But right now, let's see if anybody has some material that they would like to present.
I do have something which I didn't send out ahead of time.
That's not a cardinal sin.
Yes, but sometimes I try.
Yes, you do.
Plan ahead. Anyway, for a year or so now, I have had a subscription, which is free, to a magazine called Hakai. It's Hakai. And I put the link in the chat if other people want to look it up. It's kind of a ecologically oriented magazine. It's not a pure research magazine, but it has some fascinating articles mostly about climate change and ecological issues around the world, but particularly in coastal areas.
Where does it come from?
It comes from Canada.
Uh-huh.
Oh, okay.
Anyway, the article that I just read that I thought was really fascinating, because I hadn't heard anything about it before, is a phenomenon called the Milky Ocean. And I think a lot of us have heard about or seen even bioluminescence in the water. And there are a lot of different kinds of animals that bioluminesce. This article that I'm going to talk about that you can actually look up if you want to, is entitled "And Then the Sea Glowed a Magnificent Milky Green." And it happened about 12 years ago when an environmental scientist was on a ship in Southeast Asia in general, and he was standing out on the deck one night, and there was no moon, and there really weren't any stars, and it was really, really black. And he started noticing that the sails were becoming lighter. And then he looked down at the ocean, and the whole ocean, not just in little sparkles like you would normally see from plankton or things, but the entire ocean was turning this beautiful milky green color. And
excuse me, what
yes.
was the word you used about that ocean? You said it's some kind of an ocean.
In Southeast Asia.
No, at the start of your talk before you.
Oh, the Milky Sea.
Oh, the Milky Sea. Okay.
Yeah. And he did, and they were engulfed in this Milky Sea for hours, for quite a long time. And the boat was moving the whole time. So it was really large.
Yeah.
And it was quite uniform.
Oh,
And
that's interesting.
yeah, he decided to try to find out a little bit more about it, and learned that mariners from the 17th century even had noted seeing this phenomenon, but nobody
Really?
knew.
Really? Oh, wow.
Yes.
Sorry.
And nobody knew what it was. And of course, in before the 20th century, there were all sorts of religious and spiritual definitions of what it meant. Some people thought it meant that the end of the world was coming. you know, by the 20th century, people knew about bioluminescence and they suspected that it had something to do with that. But they really didn't know because it happens totally randomly. And in order for anyone to see it, you just happen to be there. And there's, of course, a lot of ocean. But I think it was, they started to learn a little bit more about it in 1985 when a marine biologist who was studying bioluminescence, they encountered it and they were able to sample the water and discovered that the water had huge amounts of a bioluminescent bacterium. The bacterium is called Vibrio harveyi, and it's a very common bacteria found all over, and it's known to luminesce. And they saw that it was attached to pieces of algae, so that there could be a lot of bacteria in one place. And that is the only time when a marine scientist has been able to be where this Milky Sea is happening. You know, that was in 1985. So everything that they've learned about it since is kind of after the fact and at a distance. But they've come up with some really interesting theories, you know, because this bacterium is dispersed throughout the ocean all the time. They've come up with ideas of well, how does it clump together enough so that there can be multiple square miles of ocean covered in this bioluminescence, so it looks like a uniform carpet in the ocean. And what they have discovered, and this is all laboratory work about this bacteria, is that for one, it survives a lot better inside the bodies of animals, you know, like fish. And that it wants to be eaten. And
for heaven's sakes.
yeah, so it has a chemical that under some circumstances, which they don't know exactly yet, this chemical is released and it attracts others of the same bacterium. And that's how they clump together. And then the more clumped together they are, the more predators are going to come around to eat them. And that's what they actually want, you know, because they're not digested. They live, you know, just like we have bacteria living inside of us. This particular bacteria lives inside of fish and of all sorts. Now, there's still a lot they don't know, but one of the most interesting things that I found in this article was that somebody who works for the NOAA, National Oceanic and Atmospheric Association in Denver, who got kind of interested in this, thought, well, I wonder if I can look at old satellite data and whether the satellite data is detailed enough that I could pick out times and places in the ocean where this might have been happening. And it turns out that you can. And so what they're trying to do now, because they've discovered that about 70% of this phenomenon happens in the Southeast Asian Sea And 17% of it happens, this is from data from old satellites, 17% of it happens around Java, I think. And so they're getting enough historical data that they might be able to then predict close enough, and the fact that some of them last for days, that they can actually send a ship with a marine biologist on board to the Milky Sea when it's still happening. Anyway, I just thought that was so fun to learn about.
I wonder if in the historical record, there might also, in addition to the satellite imaging trace, there might be something. It just seems so strange to me that this isn't like embedded in the mythology of some culture. It seems like it would be, put it that way.
This article mentioned the log of a ship captain from 1854 who sailed through it in his comments, and there were a few others. But the problem apparently is that even though this phenomenon can cover many square miles, it's really random whether a boat's going to be there at that time. So most sailors have never seen it.
Did they mention anything about it ever being seen in the Atlantic Ocean?
No, they didn't say it wasn't. They just said, based on the satellite data, that most of it was in those two areas I mentioned, the South Asia Sea and near Java. And they're not sure whether there are, ocean conditions
Sure.
that make it more likely to happen then. I mean, it's certainly somewhat dependent upon both broad ocean currents and local ocean currents. And how that things move over the surface of the water, but they move up and down too.
Did they say
Yeah,
anything
that's true.
about seasonality, that these guys do this only in certain seasons?
This little article, I don't think mentioned the seasons.
How about water temperature?
No, as I said, this
Nothing.
was not a
Interesting.
particular research article, and I don't know that, because it's been observed, literally observed so few times, they wouldn't know the water temperature, and probably you could get water temperature from the satellite data, but that was not mentioned.
Does this mean that the bacteria have intentionality?
Well, they didn't say that, but I've been reading other things, and you could, in fact, describe
that.
a lot of behavior of very simple organisms as intentional.
Like the virus is wanting to stay alive.
Or something like
So
that.
they
Yes.
infected other
Yeah,
people.
and they have developed mechanisms so that can happen.
But
Right.
it's not a virus, it's a bacterium.
Yeah, it's a bacteria.
Right.
Yeah,
It's much bigger than a virus.
Well,
Mhm.
now that's
yeah.
And it's interesting.
fascinating to me. Back before I went in service, I had been down by Santa Monica Pier, just south of the pier in the Muscle Beach area. And I was walking along, and my footsteps vibration caused this to flood to be noticeable, and it was the sand that I was walking on. I at the time I looked for it, and it was because I was walking past the pier in Santa Monica, just to the south end, north end of the pier, or north of the pier. And I was walking along, and my footprints were causing bioluminescence.
Mhm.
And that happened on several occasions. And I asked, I had a cop come along the top of the pier, and he says, "What you doing down there, kid?"
And I'll bet.
Normal thing for a cop to say. And I said, I'm watching the paramecium dinoflagellate. And he says, "What's that?" And I said, it's where I'm walking on the sand, right where the wash and the rewash takes place. And it was quite obvious. And it lasted a good 20 minutes, a couple of times that I was at Santa Monica. And now what I came up with is, was that? And somebody said it was the paramecium dinoflagellate that was bioluminescing due to my stepping on the sand. And I saw that several times.
Yes.
And the cop said, what's that? I said, that's what they told me anyway.
Well, there's a couple of things. First of all, I just quickly looked up on my phone, Vibrio RVI, and it said that it's a major pathogen of shrimp, fish, and things like that grown in aquaculture in Asia. It's a big problem because it causes these animals to die, and they have to try to keep it out of the water. They don't do that with antibiotics or anything like that, but that's interesting. And the other thing I wanted to say was that there was this damage to this pipeline that carries gas from Russia to Germany.
Yeah.
And the escaping gas bubbles are visible in satellite images. And furthermore, this might surprise you, there are some satellites that are gathering spectroscopic data on what's going on. I mean, it's not only the big brother is here watching us, but everything is being recorded for posterity. And with the spectroscopic data, they could see clearly that what was coming out was methane. Well, of course, methane is what natural gas is, but it's just an irony.
Yes.
Well, I used to go skiing up in the mountains, and I'd come back into town, and it was so dark from the smog that you didn't need to wear glasses to keep from dazzling your eyes driving due west. And I at the time I checked on, I said, what's happening? And I said, it's paramecium dinoflagellate. And it was just the vibrations of walking on the surface was showing us. And I saw that on several occasions, just on the south side of the pier there in Santa Monica.
Mhm.
Well, just the final thing, since Vibrio, according to this, is especially a problem for shrimp, oysters, shellfish, and things like that. That if you
You get too much of anything, and it can be difficult for something else.
Yeah. The implication in the thing I read is that it doesn't bother large fish.
Well, and this stuff.
But I don't know that for sure.
The trouble is with oysters and things like that, and it can make you sick if you eat a raw oyster. So it's just always a good idea to, I don't think anybody would be tempted to eat a raw shrimp. I would.
Oh,
And if you.
no.
Oysters aren't bad, though.
You could be sick, but it's not gonna cause you to die. It's just
Mhm.
gonna cause an illness that lasts a few days
Yeah.
with diarrhea.
Did any of the articles talk about the bioluminescence of it?
No, I didn't. I didn't find any mention of bioluminescence. I guess I was thinking about the money is lost in
Yes.
in the aquaculture when their stuff they're trying to grow is attacked by Vibrio. Anyway, let's move on. And I think Sharon, you were going to
Yeah, I had
something.
a little, it was an article from The Economist that kind of captured my attention because of the recent articles about food insecurity and childhood malnutrition and so on. And the article was looking at the work that's being done in Bangladesh by a doctor named Tamid Ahmed and a doctor at Washington University in St. Louis named Jeffrey Gordon. And what they were initially trying to do was to come up with a nutritional formulation that would quickly, work with youngsters to start remediating the malnutrition and, they put on weight and that kind of thing. But as they were working through this, they discovered that some of the children had an additional problem, which was contributing to the continuation of the malnutrition. So even though they began a feeding program, the children were not thriving yet. They were not adding weight and that kind of thing. And they began looking at their intestines and found that some of these youngsters had what were called microbiomes of the gut that were impeding the nutritional supplementation from really being wholly effective. Now, that by itself was interesting, but then they dug a little further and they did some twin examinations, and they found that even in twins, sometimes one child didn't have a problem while the other child did, which was kind of very interesting. And they said the form of malnutrition, okay, now this, I'm going to slaughter this, is called kwashiorkor.
Oh,
Well,
for
sure,
sure.
yeah.
Oh, okay. And I'm glad I didn't so mispronounce it. Anyway,
Oh, no.
they did some various kinds of experiments, including fecal transplants in lab animals and stuff like that. And they continued to work, their goal still being what would be the optimized diet for these youngsters to get past all of these problems and to begin to have them thrive again. And ultimately, they came up with 3 diets, and one turned out to be the bingo. And where previous diets have used things like legumes and nuts and that sort of thing, this diet used bananas, chickpeas, peanuts, and soya, and they mixed it together. They said it looks absolutely dreadful.
But I
It
bet it
looks.
would taste good. I thought
I
bananas.
thought it with bananas and nuts it would taste good,
Bananas, yeah.
but it was hard to get down the kids because it's brown and sticky and kind of. But they relied on mothers to do that, and of course they were successful. And
So how
they
did they come up with those combination of foods?
they had 3 different diets, and they just tried different combinations of things. And they started off looking at the things that historically have been used, which were rice, lentils, sugar, soya, and milk powder. And so that was kind of their base where they started, and then they started mixing things together. And they're really hoping that this is going to lead to a stable product that they can then use in treating youngsters for malnutrition in a
Mhm.
variety of locations where malnutrition is so. I think always of Malawi and
Sure.
mother.
Yeah.
But I just thought it was very, in my mind, the way you get past malnutrition is you give somebody something to eat. And it
Right.
didn't occur to me, that you give them something to eat that they can metabolize. And then the idea that they could have yet another problem impeding them. And
Mhm.
I found that, it was really very interesting to me.
Yes, yes.
So I have great hopes that perhaps this is going to lead. I know there's a product that comes in a little foil packet that's peanut based that kids just adore. And you put a little, water in it and mush it up and they just eat it right out of the packet. And so I'm hoping that maybe they'll get past it's brown and sticky part and get to something that.
Yeah. So I'm curious, because you said at the beginning that it was a certain number of these malnourished kids who were not able to metabolize and utilize the
Yes.
diet that they were given because of their gut bacteria, basically.
Correct.
Now, did that ever change?
The children, when they gave them this diet, it did.
Okay.
It did change for them.
Yeah.
And they did begin to put on weight and everything that you would want as an outcome.
Yeah, but could they eventually eat, quote, normal food if it was available?
Normal food is not discussed in the article.
Okay.
Just brown sticky paste.
Brown
Right.
sticky base. Numb.
And what country was that?
They were looking at Malawi,
Uh-huh.
but the two doctors, one is from Bangladesh and the other one is from the US. Works in St. Louis University in Missouri.
Did the article indicate that this changed their gut, their intestinal gut, so that they could,
They
so
didn't.
that it wasn't probably the study
That
wasn't
was
long
not indicated. Yeah, this was
enough.
not.
Okay.
Well, I'm sure it didn't say this either, but I'm just kind of curious as to how this compared to that stuff called Ensure. They give sick people and old people who can't eat.
They did not
They put a
address
lot of
Ensure.
They
sugar
didn't
in
talk about
Ensure.
that.
Yes, well, you're absolutely right. I think a lot of those supplemental drinks are basically empty calories.
Mm,
Yeah. But we wouldn't want to subject little ones to that.
right, yes.
Anyway, it gave me a little bit of hope. I just,
Yeah. No,
I
definitely.
have, I worry with climate change, what it means for food production and,
Oh, sure,
Yes.
with reason.
I have read the Science News or Science Newsletter
Mhm.
when I was in school, in high school. It came as a mimeograph sheet, and
just
I
for the
followed
days.
stuff in there. But I go skiing up at where was it, up near Idlewild someplace, and I'd end up in Santa Monica body surfing, and so this is this was a long time ago, but it was definitely footprints that did it, and just casually I ran into that. But the Science Newsletter is something I've subscribed to for the last 65, 70 years. And
Well,
anyway,
I'm sorry, continue.
anyway, that I'd make that tour, and as the smog was so bad coming down from Big Bear or wherever that I went skiing, Smog was so bad at that time, and you didn't need shades to keep from burning your eyeballs driving back to Santa Monica.
Well, in that
And
article,
I also ran into an interesting article in the Science newsletter that they make mealyworms. They gave a recipe for mealyworms that didn't look like that, but it was nutritious and did all sorts of good things.
well, here's another thing that I found in that article that I looked up about Vibrio harveyi, and I'll just read it. V. harveyi is known to be the etiological agent of luminous vibriosis, in which affected animals glow in the dark.
Okay,
So maybe it's something that if you're a shrimp, if you're raising
Yeah,
shrimp, that you really know about. I don't know.
I don't either.
this is apropos of not much, but I read recently. Have you seen the Fat Bear contest?
Yes.
All of you been okay. That the really smart bears wait for the salmon to die and then collect them from the bottom of the. So maybe this is a bear option here for winning the Fat Bear contest. You see,
I
you can
see.
put both the connection together out of nothing here.
Well, that seems a little contrary to common sense.
Oh, well.
Does anyone else have anything to present or a comment they want to make?
There was some efforts. I think it was about a year and a half ago. They're trying to develop an aircraft that will fly above the speed of sound, except coming down into lower elevations, where it would make a rattle or a rumble rather than a big sound barrier kaboom.
Yes.
And they were trying to find out if they could do that. Then they could do supersonic and fly normally above or below that, but it wouldn't be throwing people out of their beds as it came by. And I've also heard that they have whoever was going to make the plane to do this testing, and they did some of this maybe half a dozen years ago, that it would just go like that. But I know they did that because I heard that 6 months ago, something like that they were doing tests on that. But that the one that the company that was going to do the engine pulled out. But that did happen. That did happen a couple, I think 3 or 4 years ago. I don't remember exactly when it was, but it was an idea is that the supersonic jets, they kaboom real good. So they were going to try and get it, and they had low flying, fancy looking airplanes, jet type airplanes. And they did fly for a while, but the people making the engines for it just weren't making it. But they were coming through maybe 4,000 feet up, not hugely high. And they did some experimenting with that just in the last 2-3 years. But
Well, I thought I would talk a little bit, thinking about this talk coming up on the 24th, just a little bit about the process of birth of stars and birth of planets, because we all know that the number of exoplanets recognized now, it's a little variable depending on which source you consult, but there are thousands and thousands of them recognized. And there are more and more of them that they have seen, not only by just the fact that they passed in front of the star and caused a transient change in the luminescence of the star, but that they could study them with the bigger telescopes and see what they looked like. And that's how they got this concept of hot Jupiters that were planets that formed, they were the size of Jupiter approximately, and formed very close to their stars in a way that in the solar system it would seem impossible. And of course, all of this business is relatively recent. In the 19th century, there were astronomers using telescopes and they were describing what they saw in the sky, but they didn't really think that the stars and planets, they moved, yes, but they didn't change. You didn't have creation of new ones and so forth. They thought we had a static universe. And that's kind of laughable now, but there are still people who object to the concept of the Big Bang. I mean, scientists, and there are all kinds of theories of an oscillating universe where there's a Big Bang, it expands for a good while, and then there's a crunch where it contracts, and there's just an ongoing cycle. Let me show something that I have here. I think I can do it. This is what I want to show first. Can everybody see this picture?
Yes.
Yes.
Yes, amazing.
Well, what this is a picture from ALMA. ALMA is, let me think, Atacama Large millimeter and submillimeter. I don't know, it's a group of radio telescopes, I believe 66 radio telescopes that are close together in the Atacama Desert in Chile, where a lot of
the big,
astronomical things are.
what is that? The big array or something like that?
It is a big array.
Yes. Yeah. That was in my science news.
Anyway, so
months ago.
These are radio telescopes. They're not optical telescopes of any kind. And the first observation is of a cluster where, and again, these are magnetic and radio signals that are being detected here. Nothing is optical, but a cluster where it's believed stars are being born. And then here's another picture that's sort of trying to give the idea of a chaotic mixture of stars, and surrounding the stars are dust particles. It's kind of a funny thing that
What is surrounding the stars?
dust
Oh,
particles.
dust. Okay,
That's-
okay.
There's no question that there's tend to be clusters of dust that aggregate, and that seems to be that process, which is not too well understood, but is partly driven by gravitation, seems to be the main process that gives rise to stars being born. Now, here's another thing. I think many of you will recognize this. This is the so-called
Horsehead
Nebula.
Oh.
Nebula.
And this is very far away from Earth, but you can see how it does. And of course, when you look at it, this is in an optical telescope. It's mostly dark crap, whatever it is. It's forming an interesting shape. Now, the same Horsehead Nebula doesn't look quite the same in infrared.
Oh, wow.
And there are lots of these glowing things are all stars, and some of them are very young stars that are not very well established in their life. And it's clear that for these young stars, they don't have planets. When you go looking for planets around a star, it has to be a mature star. So one thing is that first stars get formed. But then why in the heck do we so often find that this agglutination of dust gives rise to then the so-called protoplanetary disk and planets forming around that? It's kind of amazing. I want to make this bigger.
You're not sharing yet.
There
Oh,
you,
yeah.
oh,
There you
there it
go.
is.
Now you can see it.
Yes,
Oh,
yes.
Okay, this is a series of pictures from ALMA again. So again, this is radio telescopes, not ocular, not visual, not an important point about genesis of stars in these dust clouds is optical telescopes can only see the clouds of dust. And that's a real advantage, for instance, of the Webb telescope and other infrared instruments, because they can penetrate the dust pretty well. Now, can you see these images here that are disks?
Yes,
mhm.
Well, this is just a theory. You can see it's an artist's conception, but it's what they see in the early stages of star formation. But in a very large star, it's a different pattern. The stars are not forming in a logical, arbitrary, in a logical way. Now, here's an example. You can probably read where it says this is a massive young, this thing here is a protostar. And these purplish things are just dust clouds around it. And these things here, the green and red things, are just jets of stuff moving in and out of moving into the star or being ejected from the star. So this is an example of process of star formation that is not following that orderly thing that I showed you that was circling around. Now, I think this will bring us to a video, and I'll try to show it if we can find it. Here it is, here's a video. And now whether it will really show, I don't know. May not. Well, I can't bring it up. What it was is, of course, the time course of formation of a star is a couple of million years. So in the time that humans are making observations, that's not changing very much. But the interesting point is that stars are formed much more rapidly, even though it's a million years, than are the planets that are formed from the dust left over, which often forms a disk. I'm sorry, I can't seem to get this video to behave. So I'm going to turn it off. So the important thing is that it's not expected that they're going to send any more regular telescopes like Hubble up, because it seems that they can get so much data from the infrared telescopes that it doesn't make sense. And an important difference is the Hubble telescope, which is still out there and still is getting useful data, is Earth temperature. It's not very far away, and it's of course influenced by the sun passing by. But the infrared telescopes have to be super cool. I mean, cooled down almost to 300 degrees below zero. And if you think about it, you can probably understand why. Does anyone have a suggestion why they have to be super cool? Well, the reason is that if you had the infrared telescope here sitting next to us on Earth, it would be picking up all the heat. Remember, infrared is heat. It would be picking up all the heat from us.
From everything
And
around.
so you couldn't get anything useful in the image. Even, for instance, the barrel of the telescope would be, which is, we don't think of as being super hot, would be giving off heat. Everything gives off heat in varying degrees. So in order to avoid that and get a really clear picture, the telescope has to be very, very cold. And so in the case of the Webb telescope, it has to be positioned at a point in space where the sun and Earth are on the same side of it at all times. And it has this ginormous sun shield, which is much bigger than the telescope. And the amazing thing is when you look at how all these things were folded up together in the launch vehicle, and then all unfolded just according to plan, a little at a time, and it all went according to plan. It's kind of amazing. There are many hundreds of steps there, and every one had to work.
Right.
Isn't
Sun
that
shield is the size of a tennis court.
Yes.
Mm.
Whereas the
the Lagrange point
Yes.
telescope that far back the stuff was infrared to find the 4.5 billion years ago. They're looking in the deep red.
yes, well, of course,
I'm sorry.
I said, of course, the Big Bang was more than 4.5 billion years ago.
Ah,
That's about
It is,
the
but-
time the sun gave rise to these planets like we're on.
yes.
But it is amazing, and when you think of it, it's a little bit of an exaggeration, but it's not completely so, to say that they're looking back to the earliest points of time.
Right.
Mhm.
It's just amazing. And this Dr. Werner, who's going to talk on the 24th, was in charge of the Spitzer Space Telescope, which is a much smaller thing. I have a picture of him standing next to the
Oh, wow.
telescope, and it's about twice as long as he is tall. But it's not all that big. And it has a barrel surrounding the receiving parts, but the Webb does not. If you see the Webb there, this thing looks crazy with those things that look like crackers sticking out. And those are the receiving parts, the mirrors.
Right.
There's still a place for the radio telescopes. They're not going to disappear. And as you know, the biggest one on Earth was this Arecibo telescope in Puerto Rico. But by this, in this big
Oh,
hurricane, not
Yeah.
the present hurricane, but the one before,
Speaking.
it destroyed that Arecibo array of radio telescopes, the biggest in the world. But anyway, these guys in Atacama are ready to challenge anybody. And China is supposedly building some very large radio telescopes too. So they give a different picture, which is, remember we discovered, well, we didn't discover it, Maxwell discovered it, that magnetism, electricity, and all those things are all the same. And so that's what the radio telescopes see, are radio and magnetic waves both. And it's amazing how fruitful that is. So the Spitzer telescope was named after Lyman Spitzer, not after Spitzer College or anything. Important man in the past. And originally it was only going to be up for 3 years. But once they got it up and started getting pictures from outside the Earth's atmosphere and everything, people said, hey, these are good pictures, let's keep it going. So it was continued for 17 years, and I think it could have been continued a bit longer than that. And it did not have anything like the resolving power of the Webb telescope, or even of the Hubble telescope. Just an interesting thing to think about is the Webb telescope has 100 times the resolving power of Hubble, which is was pretty damn good.
Right.
And so it's going to take a while until people compile a lot of images from the Webb telescope and study them. You can't really say too much first images, but it's just interesting. Now, when you say infrared, the infrared spectrum is quite long, and so the Webb telescope has 2 infrared detectors, one for near infrared or higher up. That looks nice. And I have used infrared photographic film in the past. And what you see with that is, again, it's just a slice of the infrared spectrum. It doesn't show people glowing or anything like that. So the infrared spectrum is enormous, and depending on what part of it you're working with, you get different pictures.
Yep.
So that was really all that I wanted to say. I'm sorry that I couldn't get that movie to work because it was interesting.
Yeah. Well, I think I'm going to go check out the ALMA website.
Yes,
So that looks interesting.
yes.
I also, I don't know whether anyone else has encountered or read a review of this book, but I am in the process of slogging through a book. The title is Existential Physics, a Scientist's Guide to Life's Biggest Questions.
Oh gosh, that's strange.
Yes.
Existential physics is going to give you the answer to.
No, it's not going to give you the answer to anything, but it's going to explain
More
things
questions.
so that you understand the pros and cons of the different theories.
Hmm.
And so far, it really has the most understandable explanations that I have read
Ah,
of the difference between Einstein's special relativity and general relativity. And I think I finally have my mind wrapped around it. So I'm very pleased. It is not an easy read, though, even
No, I
though
bet it
it's
isn't.
well written.
I get it.
Who is the author?
The author is Sabine, Sabine Hassenfelder. And she is a physicist, a research physicist. And it's pretty brand new. I think I read a review of it in Nature and decided that I at least had to look at it.
Well, the 3 people who got the Nobel Prize in Physics this year were all working on quantum physics and
Right.
quantum entanglement and stuff like that. And so I think that is an indication that some of these spooky quantum theory proposals seem to be bearing out.
Yes. Yeah, no, and that's the part I'm reading now about quantum physics and also quantum entanglement. Fascinating and boggling.
Well, Richard Feynman, who of course was very famous
Yes.
and got the Nobel Prize, said, of course, this was in the 1980s, he said, nobody really understands quantum theory. But I think if you can generate experiments, then you have to have some understanding of it.
Yeah. The comment of the author of this book is that because the book does not have the mathematics, fortunately, but she said it's really much easier to talk about this with math.
Of
It's very
course,
difficult to talk about it with words.
yes. Well, does anybody else have anything to say? We have time. Oh, wait a minute. We've
Yeah.
got,
Robert is here. Hi,
Yeah.
Robert.
Bob came in.
Did you catch any of it?
You're muted, Bob.
I caught just the tail end. It sounded like it was an interesting discussion. I was detained at Costco with my wife.
Okay, well, that's
That
understandable.
can get expensive.
That can get expensive.
Yes.
Hmm.
Well, I hope many of you will be able to
Yeah, on the 20.
come to the talk on the
Yes.
24th.
Yeah, that should be
Should be good.
really interesting.
Well, remember now when we had the talk on the gravitational waves, when you think about it in the abstract, gravitational waves seem pretty complicated, but that talk was very good.
Yes,
And I think this guy's knowledge of his subject is every bit as good as, what was his name, Jay Marks?
yeah.
I think Jay Marks was the person who gave that talk. So on that note, we're going to close, but I'm glad to see all of you.
Good to see you.
And I'm glad that you're in good spirits and feel that the weather is treating you better.
Is there any
Yes.
possibility that the previous episode of this group is recorded, or did that?
I don't think we
Not to my
recorded
knowledge.
any until today.
I don't think you can record without the thing intruding on you and saying you're being recorded. Do you give permission? And
Right.
at least all of the sessions I've been involved in, I don't believe any of them.
None of them have been
We
recorded.
haven't recorded up till today.
And how useful this will be to you, Bruce, I don't know, but we'll see. And I'm going to try to get Dr. Werner's permission to record his talk.
Good.
Excellent.
I appreciate that.
Okay, well,
Well, thank you, Bob,
Thank
and
you.
again for coordinating
you.
this. It's
thank
always
you all
fun.
for coming and adding your opinions. And I hope that next time Bob Wilson will get out of the store a little.
Out of Costco.
I'd like to get out. I never want to get her.
sooner.
Tell Joy, no Costco on Monday afternoon.
Okay,
Right.
pass that on.
Okay.
Your pocketbook will help
Bye-bye,
on
everybody.
that one.
Bye.
Bye now.
Bye.
Bye.